Okay, Bismillahirrahmanirrahim. So this lecture is about what? Analytical modeling of parallel system. So please imagine as we already construct our parallel process or parallel program. So we want to analyze or measure the perform of our parallel program. So how to measure our the performance of our parallel program is, so we have a few measurement, and then that measurement is called as analytical modeling. Okay, so what we are going to learn today, so we are going to look at the source of overhead in parallel programs. What are the factors that create the overhead during the parallel programs? And then what are the performance metrics? These are the measurement that we are going to look to measure our parallel program or parallel system performance. So we will look one by one of these. Okay. So let's look at the introduction. First of all of you need to know how to measure or what is called as the parallel system or the sequential system. So the first one, a sequential algorithm is evaluated by its runtime. So before we want to evaluate our parallel program or parallel algorithm, we need to know how to evaluate the sequential algorithm. So the sequential algorithm is evaluated by runtime. So runtime as a function of input size. So we need to know the runtime. Usually we from the start until the end of the program. Okay, so in general, the asymptotic or also known as a method of describing limiting behavior runtime. Okay, for example, the trend of runtime when the input size is be increased. So a sequential program is identical on any serial platform. So it said that, okay, so sequential program actually the punya runtime is identical to on any serial platform. Okay, and then how about parallel runtime? So parallel runtime, it depends on the input size. Everything is depend on the input size. Okay, the small or the large size will reflect the runtime. So not only the input size, the number of processes and also the communication parameters also reflect the parallel runtime. So as you can see that sequential algorithm ni dia punya runtime tu basically on input size je, either small or large. Okay. So however for parallel runtime it depends on three factors. First is input size, second is number of processes, and the third one is the communication of parameters. Okay. So a parallel algorithm must therefore be analyzed in the context of underlying platform. So we need to analyze or measure the performance of our parallel algorithm, whether is it uh, efficient or not. If the parallel algorithm is not efficient, better we use sequential algorithm, kan? Okay, so performance measure. So what is meant by performance measure? A number of performance measures such as the wall clock times. Usually we look at the wall clock time or CPU time. Okay, and then what is meant by wall clock time? The time from the start of the first processor. So please imagine we are running the parallel process. So from the first processor to the stopping time of the last processor. Let's say we have 3 processors being used in the parallel program. So we need to calculate the time from the first until the last, the third one. Okay. Okay, so how to measure? By using looking at the system time. Bukan guna stopwatch. And then, but how does wall clock time scale when the number of processor is changed or the program is ported to another machine altogether? So this is the issue lah. So macam mana nak tengok the workload time scale tu when the number of process is changed. Kalau kita ubah, kalau kita nak tambah number of processor, is it we need to include the time or how, kan? So how much faster is the parallel version? What is the basis of the comparison? So can we use a suboptimal serial program and so on? So we need to measure the performance. So there are many performance measure being introduced. Okay, so all of the performance measure that introduced yang kita akan tengok kejap lagi ni semua akan menjawab soalan-soalan ni ya. Okay, so first of all, let's look at the sources of the overhead. What are the factors that affects the overhead that might happen in parallel program? So the first one is called as wasted computation. Number 2 is communication between the processor, and then idling, okay, waiting time, and then contention. Contention maybe ada conflict. So these factors might cause degradation in the performance. So as you can see here, so let's say we have processor P0 until P7. Kalau you all tengok kat situ, the black, for the black color, okay, so it might happen the essential or excess computation lah to execute the program. Okay, so please imagine the black is the computation. Okay, and then the grey one is the interprocessor communication. Maybe P0 communicate with P1, P2, P5 and P7. So what else? So for white color might be idling happen in the parallel processing. Okay, so these factors might degrade the performance of the parallel programs. Okay, so you all kena remember not all parallel process ni dia bagus. Sometimes during the execution tu ada berlaku communication between the processors. Sometimes it idling because it needs to wait for the output from the other processor to be given, kan. So and then kadang-kadang algorithm yang programmer buat tu tak sama dengan programmer yang satu lagi. So ada yang programmer ni tulis panjang, yang satu lagi tulis pendek, kan. So depends on the situation or the factors. Right. Okay. So these are the explanations. So the first one is the inter-process interaction. So processes working on any non-trivial parallel problem will need to communicate to each other. Macam kita cakap tadi lah. So for example, queuing simulation. So queue so and then idling, okay, processes may be idle because load imbalance, synchronization or serial component. Apa example dia? Building up phase in parallel, quicksort and so on lah. So and then excess computation. This refers to the portion of the computation not performed by the serial version. Okay, this might be because the serial algorithm is difficult to parallelize or that some computation are repeated across processes to minimize communication. Contoh, the consolidation of grid contents after rules sought to establish heap structures. Kalau you tengok access computation ni, sometimes when we implement parallel programming, okay, dia punya coding tu, line of codes tu, it's more compared to serial version. Because of what? Sometimes during the serial version tu, bila kita parallelkan dia, it's quite difficult. Okay. So sometimes that's why dia akan dapat access computation lah. Kan it's required lots of time compared to the serial version. So these are the sources of the overhead in parallel program. So these are the example inter-process interaction. So between node 1 and node 2, node 3 ni dia ada interaction among them. So between these, ni akan affect the performance. Okay, idling. So why idling? Maybe they want to do some sorting. Okay, so they need to wait for another. Okay, they need to wait for the first level of program. Okay, to give the output for the next level. Okay, and then this one, access computation. Okay, maybe when during the serial computation, serial algorithm, okay, they use a simpler code to access or to execute the sorting and so on lah. Tapi bila dia nak parallel kan, it's quite difficult. Okay, it's require lots of codes, okay, to be used. Alright, so finish on sources of overhead. Then we are going to look at the performance metric. The first one is called as execution time. So to measure our performance, especially on parallel, so we need to look at the execution time. So we need to know on two types of execution. One is serial and second one is the parallel. So serial runtime is denoted as TS or T1. Okay, so how we want to measure the serial runtime? Okay, it said that a program is the ellipse or amount time. Okay, so we need to measure the amount of time between the start and the end of its execution on a sequential computer. So from start until the end. So that one we call as serial runtime lah. Also represented as TS. So how about parallel runtime? So parallel runtimes, we need to consider with P. What is meant by P? The processing element, because it consists of more than one processor. So it is represented as TP. Okay, so how to measure the runtime? Okay, the amount of time from the moment of the first processor, guys, start to the moment the last processor finish its execution. So we need to consider the number of processor, and then from the first processor run dia punya start dia punya execution until the last processor finish dia punya execution. It is represented as TP. Okay, so that one is called as execution time. So how to calculate, or we want to look at the formulation. So execution time. So T on, okay, represented the total time collectively spent by all the processing elements. So we want to calculate the parallel runtime tu. Dia represent as T all equals to P multiply TP. Okay. So P times TP. So observe that T all minus TS, TS is the serial sequential time, is the total time spent by all combined processes in non-useful work. Means it is called as total overhead. So the overhead function, total overhead ni is represented as TO. So TO sama dengan P times TP minus TS. So you need to remember, if you want to look at the overhead, whether the parallel program is better compared to serial or not, so we need to calculate the overhead. So to calculate the overhead, so you need to find the parallel first, P times TP, and then you minus with the serial program, which is TS. So you will get the total overhead. Okay. Alright, second one is called as speed up. So used to measure the speed of the parallel process. So of course, when we want to implement the parallel process or program, so we need to consider the speed up. Okay, we need to make sure the parallel program is fastest compared to the sequential program. So to measure the speed up, or the formulation of the speed up is represented as S. A is the ratio. So ratio of the time taken to solve a problem on a single processor to the time required to solve the same problem and on a parallel computer with P. So you need to remember, kalau parallel program ni mesti ada P. So how to calculate the speed up? S equals to TS, okay, runtimes of the sequential program, divide by TP. Okay. Or SP equals to T1 over TP. Sama je. Okay. Alright. So speed up again, the secondary objective of using more than one PE or processor is to take advantage of the larger consolidated amount of cache memory to run a big program. So why we need to use more than one processor? Because of the big program execution. So running a big program on a single PE can incur too much cache misses, thus causing thrashing effect. So that's why we use parallel processing lah. Instead of using a single processor or sequential program. Okay. Okay, so speed up measure or the value of the speed up ni can be as low as 0. The parallel program never terminates. Kalau dia 0 tu maksudnya parallel program tu tak pernah stop lah. So this happens for infinite loop, deadlock or live lock situation. So speed up in theory should be upper bounded by P. After all, we can only expect a P full speed up if we use P times as many resources. So it said that the speed up greater than P is possible. So we have to make sure lah the number of P. Kalau 2 ke 3 ke, kita kena check lah. Okay. Kalau the speed up greater than number of P is possible only if each processing element spend less time TS over P solving the problem. So this is called as super linear speed up and cannot be guaranteed. Kalau speed up kita lebih daripada number of processor, dia dipanggil super linear speed up. Tapi tak boleh garanti lah, susah nak dapat. Okay. Okay, so let's look at the example. So how to calculate the speed up? It said that, okay, so please consider the problems of parallel bubble sort. So if we use serial time to run the bubble sort, it's required 150 seconds. So however, when you use parallel time, but you implement odd even algorithm sort, it's required 40 seconds. Okay, so when you calculate this kind of numbers, okay, the speed up, so it will be appear, okay, tadi the formula of speed up is TS over TP, right? Okay, so TS is 150 over TP is 440, so you will get 3.75. So it said that it is not fair. Dia kata why is not fair? Because it not using the same algorithm. So if you need to make sure when you want to measure the performance, especially speed up, so you need to consider what kind of algorithm that you are use or you measure. Kalau tak sama, tak bolehlah kita measure sebab tak fair. Nanti confirm lah sequential yang kalah sebab dia took longer time compared to the parallel time. Okay. What if serial quick sort only took 30 second? Baru fair nak compare. So dia kata tadi quick sort 30 second dibagi 30 over 50. So the speed up is 0.75. So this is more realistic assessment of the system. Okay, compared to this one lah. So yang ni tak sesuai untuk kita measure. Kalau yang ni lebih sesuai untuk kita measure sebab dia punya masa taken time, okay, runtime dia lebih kurang sama, right? Okay, so now we look at the efficiency. Number 3, performance measure number 3 is called as efficiency. So efficiency is a measure of the fraction of time for which a processing element is usefully employed. So the formula of efficiency, E equals to S over P. S2 is speed up. P is number of processing element. Okay, so efficiency in general can be as low as 0 and as high as 1. Maksudnya when you calculate the E, so you have to make sure the punya value is between 0 and 1. Okay, so sometimes E might get more than 0 tapi tak boleh guarantee lah, susah nak dapat Okay, so next one is cost. Cost is the product of parallel runtime. So kita nak tengok cost and the number of processing element, P times TP. Okay, so cost reflects the sum of the time that each processing element spends solving the problem. Okay. A parallel system is said to be cost optimal if the cost of solving a problem on a parallel computer is asymptotically identical to serial cost. So kita nak tahu cost optimal or not. So we need to compare with the serial. So kalau sama, maksudnya dia cost efficient lah. Okay, so cost P times TP is sometimes referred to as work or processor time product. Processor time product. Okay, so last one, this is the graph. Okay, the implementation of the number of processor and then the speed up between speed up. Okay, kalau tengok ni, this is an Amdahl's law. Okay, speed up tends to saturate and efficiency drops as a consequence of Amdahl's law. Kalau you tengok kat sini, if speed up is similar to the number of processing P, number of processing, let's say the number equals to 1, speed up equals to 1, and so on, dia akan jadi linear speed up. So that linear speed up ni is called as ideal parallel system. Tapi kalau you tengok makin banyak number of processor, speed up dia makin saturate, makin tak naik So depends pada number of processor that we are use. Okay. So in case kalau kita dapat number of processor pun sama, speed up pun sama, yang ni kita dapat yang ni, kita panggil dia linear speed up. Also known as what? Apa guys? Ideal parallel system. Okay. So habis. Any question? Okay tak? Kalau okay, boleh bagi tahu madam apa performance measure yang you dah belajar tadi? Anyone? How to measure the performance of the parallel program? Wall clock time. Lagi, any answer? Anyone? Okay, so kalau jawapan wall clock time tu, for sure we need to use the wall clock time to calculate the performance Tapi kalau nak ikutkan, yang ini yang utama. Okay, execution time, the first one. Second is speed up. Okay, and then total parallel overhead, efficiency, and also the cost. So these are the performance metrics of parallel system. So all of you need to know, especially you need to remember actually so how to calculate the execution time for sequential, execution time for serial runtime, the execution time of parallel runtime, so the representation of TS, TP and so on. Okay. So T all of the total time and so on, you all kena tahu. Okay, so nak make sure you all faham, madam nak you all jawab soalan ni. Okay, so soalan A. Analytical modeling is a common issue in performance evaluation of parallel system. So explain two elements used in modeling the performance of parallel program. What are the items or factors, okay, that we need to consider? Dia kata elements kan, to use in modeling the performance of parallel program tau, bukan sequential program, parallel program. So you want to try? What are the answer? Asri jawab apa? Input size and number of processes. Betul. Satu lagi. Betul dah tu sebab dia nak dua kan. Satu lagi apa agak-agak? Anyone? Satu lagi, kalau kita parallel, yes, communication parameter. Sebab parallel ni, kita kena tahu input size. Bila dah tahu input size, berapa banyak number of processes yang nak kena proses. And then, of course, they will communicate with each other. Okay, good. So, dapat 4 markah. Okay, number B. Consider the problems of sorting numbers. Okay, sekarang kita tak tahu sorting numbers ni. Kita nak calculate the performance of using parallel bubble sort algorithm. Assume that the serial time for bubble sort is 160 seconds and the parallel time for parallelization of bubble sort. Okay, both of these runtime or algorithm are using the same algorithm, bubble sort on 4 processes is 40 seconds. So calculate the speed up and efficiency of the parallel system. Jawab yang tu dulu. Sekarang you all kena calculate the speed up and efficiency of the parallel system. Okay, how to calculate the speed up? What is the formula to calculate the speed up? So you go back to the previous slide. Okay, so this is the formula to calculate the speed up. Okay, cepat semua orang cuba. So S equals to TS over TP. So our TS berapa guys? And our TP berapa? So you cari berapa TS, berapa TP, then you need to divide lah. Then you get the answer. Okay, ada siapa-siapa dah kira? What is our speed up? Okay, Asri jawab ya. Our TS is 160. Okay, betul. T1 equals to 40. Speed up equals to 160 over 40. Speed up equals to 4. Okay, yang lain dapat tak jawapan? Betul. Betul Asri punya jawapan. Jawapan dia ialah 4. Okay Okay, 4. Oh, nanti kalau jawab dalam exam, Asri kena letak 4S or seconds. Okay 4 seconds. Kalau tidak kita tak tahu tu 4 apa, 4 minutes, 4 hours, 4 second Okay, so now kita dah cari speed up. Okay, sekarang kita kena calculate efficiency. So calculate the efficiency guys. What is the formula to calculate the efficiency? Okay, so efficiency dia kata E equals to S over P. Sekarang you dah jumpa S. So you kena bahagi dengan P je lagi. So how many P? So E equals to S over P. Okay. So you dah dapat tadi dah. S berapa? Sekarang nak masukkan dalam formula saja. Okay, anyone? Efficiency, speed up over P. P is equals to number of processes. So how many processes does the question use to execute the parallel bubble sort? Okay, Ain jawab. Okay, ramai jawab ni. Bagus. Okay, semua dapat 1. Betul. Okay, jawapan dia adalah 1. So, tadi kita tahu efficiency ni dia punya value, range dia between 0 and 1 kan. So, dia high lah kan, 1 tu kan. So, efficient dia bagus lah. Dia adalah good. Okay. Alright, so ada soalan bawah tu kata, based on the result, determine the types of parallel system and explain your answer. Kita dah tahu speed up kita berapa, efficiency kita berapa. And then, it wants to know what is the types of parallel system. So, you need to think what kind of parallel system that these problems use. Okay. Okay. So macam mana nak tahu? You kena tengok value of speed up tadi. So value of speed up tadi you dapat 4. Kan? So 4, kalau you tengok 4 tu sama tak dengan number of processes yang kita guna untuk parallel program tu? Sama kan? 4 kan? So our speed up is equals to P. Okay? So if you remember in previous slide ni kata kalau speed up kita nilai dia sama dengan nilai PE. So maksudnya kita panggil dia apa? Type jenis apa parallel tu? Yes, ideal parallel system. So nanti kalau dalam soalan ditanya macam tu, so you need to think, you need to consider, how many processes are being used? So what is our speed up just now? What is the efficiency? So you need to consider, then you know, oh our parallel system ni is ideal, apa nama tadi tu? Ideal parallel system, or also known as what tadi? linear speed up kan. Sebab apa dia linear? Sebab dia straight line macam tu. Okay. Okay, good. Right. So, ada soalan? Ada rasa ni je kot untuk hari ni sebab memang performance measure tu itu saja. So, please remember unit kadang-kadang dia soalan dia tanya pasal cost. Kadang soalan dia tanya pasal runtime saja. Kadang dia bagi this kind of figure so nanti dia suruh calculate what is the runtime and so on so dia boleh pusing-pusing soalan, but you need to make sure lah you need to remember the formulation. Okay, so